What's up everyone? Welcome to part 3 of our audio spectrum analyzer with Python, and in this video I'm going to give a quick update on where we are with the project. So as you can see, we're no longer using matplotlib, and instead we're using a library called PyQtGraph. So PyQtGraph is a lot more optimized for plotting real-time signals, mainly because it can plot a lot faster than matplotlib can, so we're getting about double the frame rate. So I'm going to walk you through the installation and show you the code to see how to use this library. So let's get started. So the first thing you're going to need to do is install PyQtGraph. And the install is a little bit different than your typical pip install or conda install. What you'll need to do is come to their website. I'll add a link in the description, but it's just pyqtgraph.org. And they actually have an exe installer if you're on Windows. So you'll just download this, run the installer, it'll install all the libraries and packages in the correct place, and then you should be ready to go. And I just want to point out the main reason why I'm using this one, like I said earlier, the number one reason why you choose this over matplotlib is speed. Like it says here, if you're doing anything requiring rapid plot updates, then this is the better choice. So yeah, I'm going to show you how to set this up. And also, if you for some reason choose not to, what I've done is I've updated the original code using matplotlib, and what I've done is created a Python file instead of a notebook, because I've noticed that just going from the notebook to a normal Python file, it actually runs a lot faster. So what I've done is cleaned up the code, turned it into a class, and I'll also share this on my GitHub. So just to show you, this is what the previous version looked like, and so it's basically the same thing, except now it's in a Python file instead of a notebook. So and you can see here we're getting about 21 frames per second, whereas before with the notebook we were getting about 15. So yeah, I'll be sharing this in my GitHub as well. So the starting point for me was I found some example code that uses PyQtGraph to animate a plot. So I'll add a link in the description to this GitHub, but I found this example code. So what I did was copy and pasted that into a new Python file. And let me just go ahead and run it to show you what it does. So here you can see we've got a sine and a cosine wave, and the phase is changing with time. So we've animated the phase to increase over time. So with this code, we can modify it to add all our audio stuff into it. So before we do that, I'd like to quickly walk through what the code is doing, especially because if you're switching from matplotlib to PyQtGraph, it's a little bit different. So let's do that first. So the first thing to point out is that PyQtGraph is built on Qt, and what Qt is a GUI application library. So you can see that we're doing some imports, Qt GUI and Qt core, which if you've ever used Qt, you're always going to import these. So another thing to point out is we're using a class, and we haven't talked about classes, but hopefully you have enough understanding of them to follow along. So in the init method, which is the first thing that always runs whenever you create a class object, we are first creating the Qt application. So from Qt GUI, we're calling QApplication, which is our app. And then what we're doing is we're creating our graphics window. So PG, if you see up top, we're importing PyQtGraph as PG. So we're creating the graphics window, resizing it, setting a title, setting some view options, and then we're creating this object called canvas. And what we're doing is we're adding a plot to our window. So that's the first thing that happens when you create the class object. So let me scroll down to the if name equals main part. So you can see here we're creating the class object called P. So remember our class is called plot2d. So we create the object, and then what we do is we create this thing called QTimer. And QTimer is very similar to the matplotlib func animation. So if you remember from the animated matplotlib video I did, we used func animation, and what it did was we passed in a function, we passed in some arguments, and then we passed in the time interval that we wanted it to update at. And we're pretty much doing the same thing. We're creating the timer, we're connecting it to a function. In this case, it's update. And then we're setting the time interval. So what update does is it's just calling some methods from the class above. We're using this method trace. So trace just adds X and Y data to our plot. And then, yeah, that's pretty much it. We're just connecting the timer to the update. And then once it's all done, we call start. And start is another method in the class. So that's a quick rundown of how this thing works. And now what I'm going to do is show you some changes that I made to clean up the code a little bit. So I'm going to start with a blank file, and to save time, I'm just going to copy and paste a lot of it in here. So what I did was I cleaned up this class a little bit, because if you notice, there's no reason to have this update method or this update function outside of the class, and all this stuff here. We can put all this into the class. So let's start with the imports. From PyQtGraph Qt, we're importing QtGUI and QtCore, NumPy, PyQtGraph is PG, and then we need sys also. So now I'm just going to copy the class and the init method. So what I did was I added this self.phase and self.t. So phase is the variable that we're going to be updating in a loop to shift the phase along. And then this is like our x-axis, though. It's self.t. And then I just sort of rearranged everything and got rid of some of the comments. So the next method is the start method, which I didn't make any changes to that. And same with trace. So we're using the exact same code for trace, so there's no change there. And then what I did was I created a new method called update. So I basically just moved update into the class. So now we're creating S and C for sine and cosine. So now we're using self.t and self.phase. So before they just called the phase I, and he created t inside here. So now we're using the t that we made above. We just moved it to the top, and then we moved this to the top. We do that, and so now when we call trace, we need to call self.trace because we're calling it within the class. And then we're just increasing the phase. So that's our update method. And then finally I created a method I called animation. So in here we're creating the timer. We're connecting it to self.update now. We're setting the time interval, and I'm just going to make it 30 to go a little faster. And now we're calling self.start. So what start is this method. Cool. So now all we need to do is our if name is equal to main. All we need to do is create our class object. So we'll just call it the same thing. P is equal to, what was it called? Plot2D. And then all we need to do is call p.animation. So now if we run this, there we go. So I forgot to close the parentheses on the class object. So here you can see we're getting the exact same thing, but now the class is a lot cleaner. It's more Pythonic and more object oriented. So that's the first step, clean up the class. So now let's add our audio stuff into here. And again, to save time, I'm going to copy and paste a lot of it. So here are the imports we need. We're going to need struct, pyaudio, and from SciPy's FFT pack, we're going to need FFT. So we need to modify this part here. So we're going to need to add 2 plots. So the way I did that was, let me copy and paste it first. So instead of calling it canvas, what I did was I called it waveform. So the first one is going to be the waveform, and you can see that I'm specifying the row and the column. And the next one is going to be called spectrum. So let me copy and paste that, move this over, and we're going to put it in the second row right below it. So that's what we're going to need here to add to the init method. And then also I'm going to add all of our variables and then the stream portion. So first thing I'll add is our variables. So if you remember, we had format, channels, rate, and chunk. And then the next thing we're going to add is the pyaudio object. So let me just come up here. We're going to add this thing called p, which was our pyaudio object. And then we're going to create this thing called stream. So it's going to be p.open, and then we pass in all of our variables: channels, rate, input, output, and frames per buffer. And you can see that everything has self in front of it now, because when you add self, what you're doing is you're creating a class attribute, and then you can access these attributes anywhere within the class. So that's the idea. You're going to see self a lot when you work with classes. Cool. So that's the stream object. And the next thing I'm going to do is add our x variables. So these are going to be the x variables for the two plots. So we've got self.x and self.f. So this is going to be like samples, and this is going to be frequencies. So pretty much the same as the previous code, except we've got self in front of everything. So that's going to do it for the init method. And next thing, let's move on to the trace method. So what I did here was I renamed it to set plot data, and I'm renaming it because if I copy and paste, I might screw something up. So what I did was, this part all stays the same, so we don't have to mess with this. But what I did was, since we have two plots that we're updating, I added an if statement. So I'll get rid of this part here. And so if the name is going to be waveform, we're going to add a new plot object into our trace dictionary, and it's going to be this waveform plot, and I'm changing the color to cyan. And then we're going to, I'm just setting the Y range and the X range. So yeah, we're just sort of formatting it a bit. And then for the spectrum part, I just add another if statement. So if the name is spectrum, we're going to do the same thing, add a plot to the spectrum entry. And then we're setting it to log mode for both X and Y. So we're going to have log in both axes. And then I'm just setting the range for Y and for X. And one thing to note about PyQtGraph and log axes, so if we were setting the range and we had log axes with matplotlib, we would give the actual value for the min and max, say for X. So it might be like 1 for the min and 10,000 for the max. With PyQtGraph, what you do is you specify the power. So it can be a little confusing. Instead of like 1, you would say 0. And if you want 10,000, you would say 4. So if that's a little confusing, what you can do is, so here I want to go from 20 to half the rate. So in order to do that, just put np.log10 around it, and then what log does is it returns the power. So it can be a little tricky, I know, but this is how you need to set your X ranges. Cool, so that should do it for our set plot method. And then the next thing, let's move on to our update method. So in this part, this is going to have all the unpacking of the audio data and then the computing the FFT. So first thing I'll do, we're going to get rid of everything, and I'm going to copy everything from my original file. So you can see here we've got an object called waveform data, and we're reading from our stream object. So we're reading one chunk of audio data, then we're unpacking it using struct, and then we're turning it into a NumPy array, slicing it and offsetting it. And then finally we're calling our set plot data. So we're giving it a name and then setting the X and Y data for it. And next we'll do the same for our spectrum data. So I'm just going to copy and paste that. So our spectrum data is, we're just taking the FFT of the waveform data. So we're converting it to a NumPy array, I'm changing it to an integer, so that way we can remove the offset. And then what I'm doing is, taking the absolute value of it, and then we're doing that rescaling to sort of normalize it, so that way all the peaks are less than 1 in the spectrum. And then we're calling set plot data again, so we're adding the plots to the windows. Cool, so that's our update method. And the animation method actually can pretty much stay the same. The one thing I did was I made this 20 to try and make this thing go as fast as possible. And with that, I think this should run. So fingers crossed, let's try it. So no, it's not running. So I'm just gonna pause the video and figure out what's wrong. Okay, we're back. So I found the problem. I had changed the names of these things from, it was like dataset X and dataset Y. I changed them to just data X and data Y. So just a little copy paste error. Once I updated that, it's working now. So let me go ahead and run it. So here you can see we've got waveform viewer on the top, spectrum viewer on the bottom. So one thing you'll notice is, like here I've got log scale for the x-axis, and the labels are kind of useless. They're so hard to understand what it is. They're all bunched together. So what we want to do is relabel it so that there are more meaningful labels. So what I'm going to do is show you how to do that now. So we'll close that. So again, I'm going to copy and paste this, but what you need to do is create a list of tuples, and each tuple will be like the coordinate and then the string label. So the simple example, let me just do the x-axis for the waveform viewer. So let me first copy it over. So where I put it was right here. So you can see I made a list. I just want to label the 0, the 2048, and the 4096. So we've got a list of tuples, and then it's the integer value, and then the label, the string label. So then the next thing you need to do is create an axes object, or an axes item. So we need to say where this thing is going to go, and it's going to be on the bottom. And then we need to set ticks. So now we're setting the ticks of this new axes item. Ticks that we're setting is this list here. So now we've got our axes item all set up. And then the last thing you need to do is specify the axes item in your plot. So if I just do, let me copy this real quick. So here, if I just add it here, so in our plot, we're adding axes items, and then we give it a dictionary. So at the bottom, we're going to give it this axes item that we created. So now, oops, when we run this, WF, oh, this is, oops, okay, so this should be, cool. So now you can see we just have 0, 2048, and 4096. So that's how you redo them. So now I'm just going to redo all of them. So quickly I'll do, I'll add the y-axis. So I'm just copying pasting the list from my other code. So here I've redone the y labels and the x labels for the top one. And then here I've just done the x labels for the spectrum viewer. So here, I'll just copy and paste those here. And then I just need to add the y-axis to our plot here. So I'm just gonna redo that here. So on the left, we're putting the y-axis items, and on the bottom is the x-axis items. And the same thing here for our spectrum plot. So we're adding our x-axis here. And then what you'll notice is that, again, like I mentioned, we don't specify 10, we're specifying the power of 10. So in order to do that, we need to wrap it in np.log10. So I really want the points 10, 100, 1000, and then finally the endpoint, which is 20, which is half the rate. So everything is wrapped in np.log10. So now if I go ahead and run this, you can see that the label is 100, 1000, and then half the rate, 22050. Cool. So that's pretty much it. I know I went through it kind of fast because there was a lot to talk about, but have a look at the code on GitHub, spend some time with it. If you have questions, feel free to ask in the comments below. And that's going to be it for this video. So before I go, I want to just talk about where I want to go with the next video. So I think the goal that I want to do is to try and make some sort of like 3D visualizer. And that's another main reason why I chose PyQtGraph. So just to give you an example, if I were to do 3D plotting with matplotlib, here's just a simple example of a 3D plot. This is taken like right from the website. So here you can see it's a sine x over x 3D plot. And if I were to zoom, or if I were to like kind of pan around, you can see how slow this update is going. It's really choppy, maybe getting like a frame or two per second. And honestly, the graph is kind of ugly. To me, this isn't like a very pleasing looking graph. But if we were to do the exact same thing using PyQtGraph and OpenGL, let me show you what that looks like. So let me run this. So here's basically the same thing with PyQtGraph and OpenGL. And you can see how smooth it is, how easily and fluid it is to rotate. And actually it's a lot prettier. We can, really zoom in on it, and everything's smooth and there's no lag or anything like that. So the next step will be to try and take this and animate the 3D plots and try and do something that you'd see in like a visualizer, some sort of like artistic thing. Like just think of the iTunes visualizer, and that's what I'm going for. So that's going to be the next video. Like I said, if you have questions, leave them below. I'll try my best to answer them. Don't forget the Facebook group where you can chat with me. And yeah, stay tuned for the next one. See you guys.